Welcome to all of you out there. Thank you so much for joining us for the Getting Apollo Astronauts to the Moon and Safely Back to Earth webinar. We're actually broadcasting to you from the NASA Johnson Space Center in Houston, Texas. Houston, we're hoping we don't have any technical problems today because we really look forward to sharing a lot of information with you today. First of all, we have registered participants from 27 states plus Washington, D.C. Whether you're joining us live or watching the archive, we're so glad to be connecting with you, both informal as well as formal educators. This webinar would not be possible without our featured speaker, Jerry Woodfill. Jerry is such a dynamic and excited and passionate individual who loves to share his story. And I think you will get a sense of how passionate he is about his work. He's only been working at NASA for about 54 years, and he still certainly seems as though he still loves what he does. So Jerry is the first of hopefully many other speakers we'll have for webinars. You can always check our webinar website for additional webinars we may be hosting in the future. Again, my name is Paige Graff, and I'm sort of the lead facilitator for the session. Suzanne Foxworth, as well as Brooks Mitchell, will also be communicating with you in the chat window and perhaps even in the Q&A area. So with that, that's my little brief introduction because I want to turn things over to Jerry. So Jerry, let's turn things over to you.
Well, good afternoon. It's great to have this opportunity. I'm honored because after 54 years, you know, it's great that this is an opportunity to share my career with everyone. And the first slide kind of shows where I was from Indiana at about age 7 and where I was when I helped Neil Armstrong land on the moon a few years later. But anyway, this is a wonderful opportunity to share my life with everybody that's online. So let's go to the next one, Paige. And I'm from Indiana. Of course, Indiana loves the game of basketball with a passion, and so did I. And so as a Hoosier basketball player, it was my dream to be a college player. Go to the next one. And to be a college player, you know, you have to do well in high school. And between 5th grade and 12th grade in high school, I counted up 8,000 hours practicing basketball, and I was averaging 10 points a game. Not too good. But in the state tournament, in the 4th game of the state tournament against the #1 team in the state, which you see this picture of, I'm number 30, I had a miracle game. I was unstoppable. I was like Spider-Man in jockey shorts. I could not be stopped. And I scored 20 points against the finest defensive man ever played Indiana high school basketball. And so as a result of that, go to the next one, I got a full basketball scholarship to Rice University based on one game. Now, I give this program to a lot of students, and many of them say, well, I haven't had my dream fulfilled. Well, believe me, one thing can happen, like it did to me. One thing can happen that can change the whole perspective of your life. So failure is never an option because there's always a future. It can happen to you like it happened to me. Go to the next one. Okay, so here I was playing basketball at Rice. That's me, number 30. The guy, number 14, we're against Tulane. That's Kendall Ryan. He's about 7 foot. He went on to the NBA. And go to the next one. Obviously, I didn't, even though they thought I was going to be a great player. In fact, the newspaper came out and interviewed me. Go to the next one. And there I am. They interviewed me. I was from Indiana, so they thought, I must be a great basketball player. Well, I proved them wrong. In fact, I have records at Rice University. I have the lowest shooting percentage anybody that ever put on a Rice jersey. I only made one shot, and the one shot I made was against Baylor University. Our center was under the basket. I threw him a pass. It went in the basket. I made a bad pass. I tried 18 shots. I never made one but a bad pass. Horrible basketball career. Didn't look like I had any future. Go to the next one, Paige. But in 1961, it was July 25th, John Kennedy came before Congress and he made this commitment. He wanted the nation to reach the moon before the decade was out. But what he said really set the course of my career, because he said not only to put a man on the moon, but he said to return him safely to Earth. And little did I know that that was to be my destiny. That was sort of a prophecy of what my life at NASA would be, to return the astronaut safely to the Earth. Go to the next one. Okay. So my Apollo career would be the employee assigned President Kennedy's charge of returning him safely to the Earth. And I was what was called the caution and warning project engineer. That is, both the lunar lander, the Eagle, and the Columbia, the mothership, the command ship, called the Columbia, would have alarm systems. And I was in charge of both those systems. And so to do the job that I was supposed to do, I had to make sure they worked correctly and they would save astronauts' lives, as well as warn them if there would be the prospect of some kind of a life-threatening failure. Go to the next one. And so here's what really changed my life. I was a student, of course, at Rice, doing poorly in basketball. And by the way, academically, I wasn't doing so well either. I set some records there, academic records, not good ones, but bad ones. But then my teammate said, Jerry, come on down to Rice Stadium. John Kennedy's going to talk about going to the moon. Well, obviously, I'm not going on the NBA, but, you know, I'd like to hear what the president had to say about going to the moon. Go to the next one. And so this is a thing, a talk. I give this talk over and over again. I give it about 60 to 100 times a year. And when I go out, I always give a portion of John Kennedy's message that I've memorized. And to do so, I like to use the presidential seal. Now, I work for NASA. And of course, you know, I wanted to keep everything legal. And so I wrote the White House and I asked if I could use the presidential seal. And I got a letter back, oh, no, just the president uses his own seal. Well, that's logical. But I still wanted to use the seal for my message. So if you can show this, this is the seal. This is my seal. And if you notice, there's no, oh, there it is. There's no P there. So this makes it legal. This is the residential seal of a resident of the United States, and that's who I am. And so when I go out, I just give you just a little snippet of what I see. Despite the striking fact that most of the scientists the world has ever known are alive and working today, despite the fact that this nation's own scientific manpower is doubling every 12 years, despite the fact that the vast stretches of the unknown and unfinished far outstrip our collective comprehension, no man can fully grasp how far, how fast we have come. And this is a breathtaking pace, and such a pace cannot create new ills as it dispels the old, new ignorance, new problems, new dangers. Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why he wanted to climb it. And he said, because it is there. Well, space is there, and we're going to climb it. And the moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked. Thank you. And so when I heard that, and he said there'd be a hazardous and dangerous adventure, little did I know that my job was going to be focusing on making that adventure less hazardous and less dangerous. So I left Rice Stadium, and I left there with an intent to do well. I gave up my basketball scholarship, by the way. President Kennedy blessed the Rice Athletic Department, but I focused on academics, and I made a B average my final 2 years and graduated with a degree in electrical engineering, a BS and a ME degree, not an ME, BA degree. Next one, page, okay. Next
and
one.
you got some virtual claps there as well. So okay. Virtual claps all around.
That's wonderful. Okay, so here it is. This is the whole summary of what happened. I made the lowest grade ever made in differential equation at Rice, and not just an F, I made an F minus. Now, it didn't look like I had any future at all. And then I just told you how my basketball career was even worse. But I heard that message. That message was life-changing. And I graduated at the bottom of my electrical engineering class, but I always like to see, if you see it says I was 11th of 13, well, I think that's providential. I talk about Apollo 11 and, of course, about Apollo 13, you know, so I think, well, maybe that was to be. But nevertheless, President John Kennedy's message changed my life, and I like to share that with students, that your life can be changed by one little thing. Could be from a president, could be from a friend, a parent, a teacher, so forth. So don't ever give up. Press on. Go to the next one. Okay, so NASA made me an offer. I became the Apollo spacecraft warning system engineer. It's a term for it. It's a failure engineer. Of course, I knew how to fail. But better than that, I knew how to recover from failure, and it was an offer I couldn't refuse, the only one I had. So, you know, I was on, my first job was to work for NASA. Go to the next one. And that's what I look like. It's discouraging to see what the ravages of time can do to the human body. Now, that was my face then, and that's my face now, you know, but it's been a few years. And so anyway, that was 54 years ago when I was hired. That's what I look like at my first day at NASA. Go to the next one. Okay, so shortly after I was hired, they put me in charge of the alarm system. Now, I had to go out to the manufacturer of the Spacecraft 12. That was North American Aviation down in California. And this is the trip report that I wrote after I went out there. When I got out there, now I was only 22 or 23 years old. And here that was thrown at me. I'm the guy responsible for the alarm system. And the alarm system had what they call chits, that is, anomalies written against it during testing. There were 150 anomalies. Now, that's a pretty tough job. I was like an attorney trying to defend my system against all the other systems that said, it's the warning system's fault. I said, no, guys, it's not. The warning system is doing its job. It's just telling you that you need to correct some things. And after all was said and done, and I had defended the system, it came to only one alarm that had to be explained. It was O2 flow high, and it really wasn't my system at fault. So I'd like to share that with young students that are taking a job. You may be thrust into like a furnace, but don't give up. You've been educated, and you've got that within yourself to be your own advocate to say what is the real situation. Go to the next one. Well, on that trip, I met an astronaut when I checked in to the North American plant, and he was checking in. His name was Roger Chaffee, a Purdue graduate, a young man, about 30 years old, and I got to like him, a very nice person, very brilliant person. And during that week, when we reviewed all the anomalies on the alarm system, Roger helped me. In fact, he gave me some suggestions on how to do things and procedurally make the alarm system better to be used by the crew on their route to the moon. Go to the next one. And so the thing was, I left that plant, and I remember that final review that they had at the plant. And here are all these supervisors and managers from NASA headquarters and Manned Spacecraft Center and all the engineers. And I was called up to speak and defend the alarm system. And I can still remember seeing Roger Chaffee and Ed White and Gus Grissom sitting in the front of the room as I began to explain, and everybody explained. And the next thing I knew, when I'd gone back to Houston and I was having dinner one night, I heard on the television, there's been an accident at Cape Kennedy. And what had happened was, underneath Gus's couch, there was a short circuit in one of the harnesses that ignited the flammable materials on board. And it was a terrible design. It was called Spacecraft 12, terrible design. And the reason that my alarm system wasn't able to ring the alarm was that it was a problem that just happened momentarily, just like that. And there was actually no fire extinguisher or anything on board to do much. In fact, it took 5 minutes to get the hatch open. And so I've always wondered, what could I have done better? And as I've reflected on that over the last 45 years, I don't know of anything that I could have done, but I thought I had done the best job I could. But I tried to help redesign the alarm system so that future crews on going to the moon would have a very safe situation because they would hear an alarm if there was a problem. Go to the next one. And that was what my panels, see those panels that look like? Those are the panels that indicate whether there is anything wrong. And when they opened up the hatch and they had to remove Gus and Ed's and Roger's bodies, they found that one of those lights was on, and the light was O2 flow high. And that was the alarm that I had to speak to back at North America. And that alarm should have been on, because as soon as the fire started to engulf the cabin, the pressure system that would have put O2 into the cabin should have turned it on, because the oxygen flow had to be high. So really, my alarm system didn't do anything wrong, but then it didn't help to solve anything either. So it affected my life greatly. Go to the next one. Okay, so this is why it affected my life. Because of the seriousness of having a fire on board, the thought was, well, what if that kind of thing would happen on the route to the moon? And the manager of the entire spacecraft program's name was George Low. And he said, we need another group. We need a group of people like Jerry and the environmental designers and the power designer, the actual engineers that had actually tested all these systems, were responsible for exactly how they worked. And we had to have them available if we had a problem like the Apollo 1 problem on the way to the moon. And so he created what is called the Mission Evaluation Room, and it was led by a gentleman by the name of Don Arabian. And Don was a fierce engineer, and you didn't give Don any lip, because he would tell you exactly what you needed to know and report, and you had to know your system, or Don would really find out very quickly that you didn't. So go to the next one. And so there we were. And before we could even launch an Apollo mission. Now, people don't know this, and this is why it's so wonderful that I can share these stories, because I don't share them as an astronaut or a flight controller. I'm an engineer. I'm one of the guys that designed the craft. I know how it worked. I had worked to test it. I had signed documents that say it's a reliable system. My alarm system was. And that is a very special thing. You know, you have the acronym STEM. It is not a plant. It represents science, technology, engineering, and mathematics. And there's E, the big E, the big E. And that's what I am, and that's what we are. And he put us, George Lowe, in a room that was called the Mission Evaluation Room. Should have been called the Mission Engineering Room, but to put the word evaluation in. And before you could even launch an Apollo mission, if you've seen the movie Apollo 13, you see Gene Kranz calling out all the flight controllers. Well, what's never shown was that our leader, George Lowe, and Don Arabian were in communication. And George Lowe was at Cape Kennedy. And he would call Don Arabian and say, Don, do your troops in the MER say go? And when Don would say to George, go, well, then George would say, yep, we're ready to go, flight. And so besides the flight controller, there was also the mission evaluation room that had to give the go-ahead. Go ahead in that next one. And so for all these missions, the alarm system I was responsible for the lander as well as the mothership, had the alarm system on board. The alarm system was like a virtual astronaut. You know, when the astronauts are behind the moon, they can't communicate with flight control. And so when they want to sleep, you know, it's the alarm system that's there as the fourth man in the command ship. And when you're re-enter Earth's atmosphere and there's a blackout, the alarm system can be heard by the astronauts. So it's there as a virtual astronaut in all of those periods of time when there is no flight controller oversight. Go to the next one. And so there we were. Now, this is really primitive. I want everybody to look at it. Do you see this? Do you see those concepts? That's what we had. That's how we had to judge from our measurements. And there I am in the front left of the picture. You see, I'm the only guy in the room with had a tie on. Most of the NASA guys never wore ties, but the engineers for the contracting companies, the LEM with the Grumman and the North American guys of the command ship, they would all wear ties. And the reason I had a tie on, this is not the same tie, it's my Apollo tie. But anyway, my wife said, Jerry, all my friends' husbands work for IDM, and I'd like to see you wear a tie. So that's why I have a picture of a tie there. But look at how primitive it is. You see that? We're in picnic tables. You know, we don't have consoles like the flight controllers had. In fact, we're so primitive. You know, we didn't even have a headset. There's no microphones on our headset. If we wanted to talk to anybody, here's what we had to use. We had to use a phone. You know, that was all we had. And the worst part about it was, if you go back to the picture of the room, look at that, return to that previous slide, and you see those consoles up there. They're so far away. Now, I had good eyes in those days before I needed, you know, these things. And in order to see those things, the guys that didn't have such good eyes, we'd have to be like Columbus, you know, walking, and we'd have to see what the measurements are. That's how those our consoles were just 19-inch black and white TVs. And if we want to have a data recording, the only way we could record data to review it, if we want it quickly, we had to have one of these things. You see this? This is a camera. It was a Polaroid camera, and we'd have to take a picture of the display, and it took a minute to develop this thing. And so we had data in a minute. You know, the flight controllers, they could get theirs in, you know, a millisecond, but we had a minute to get ours. So, you know, it was primitive. But go to the next one. Despite that, we were able to do the kinds of things that actually saved many of the missions, because we were innovative and knowing the hardware and having designed it and tested it, you know it's very familiar to you. And so, for example, when Neil Armstrong was going to land on the moon, I was instructed to write down in a procedure, go to the next one. And here's the procedure. When he turned on the Eagle, he would be able to look at those panel of lights from the alarm system. And I had to write down there which lights would be on, because the systems had not been activated to come up to proper temperature or voltage or anything like that. And if it didn't identify with what I had written in this procedure, there was a problem that had to be dealt with. Go to the next one. And so my role, July 20th of 1969, had my headset on, and all of a sudden, they were approaching Tranquility Base, and what had happened was there was an issue that I had on my system. It's called nuisance alarms, and that is a situation where, for example, you're in your home, and all of a sudden your lights get dim, and what you find out was that your air conditioner, the compressor had turned on, and it pulled down the voltage of the house, and your lights get dim. Well, my system was sensitive to that kind of thing. And when you'd switch an inverter or do some other thing that turns on, there'd be an alarm that would come on. And when that alarm comes, if you didn't write in the procedure to expect that alarm, that was very distressing to the astronauts. And you didn't want to have that happen. Like when Neil would be coming down to Tranquility Base, you certainly didn't want to have a nuisance alarm that would trouble him, or perhaps even made him jerk the control stick. That's very bad. And so that's one of the main things I had to deal with during my career as the alarm system engineer, to get rid of nuisance alarms. And so Neil's coming towards Tranquility Base, and all of a sudden it's a nuisance alarm. It's something that really was not a problem, except that it looked like it was. It was called the program alarm. And it's a long explanation, but there was a very bright MIT Draper Labs woman by the name of Margaret Hamilton that had come up with multitasking. and she had given priority to the landing program. And so when this program alarm came on, even if we hadn't done anything, it still would have brought Neil down so that he could land. And it was an ancillary alarm. But nevertheless, the fact that it came on was very troubling. And so what happened was the flight controllers, my friend Steve Bales, and then in the back room, Jack Garman, they had actually, because of a sim that they had just 2 weeks before the landing on the moon, they had gone through a sim, and a sim supervisor named of Dick Coos had thrown that into the sim that the program alarm came on, and Steve, he aborted on that. And when they went back and talked to Dick Coos said, you shouldn't have aborted on that. You should have continued on. Well, because of the SimSup and Dick Coors putting that in, and then because Jack Garman put down all the kinds of things that would turn on the 1201 and 2 alarm, because they knew that in advance when that alarm actually came up. It's amazing. The alarm that actually would almost cause Neil to have to abort was just practiced 2 weeks before. You talk about providence in the hand, that has to be. In fact, Steve Bales and I remember going to the same church, and he told me one time, it's amazing, Jerry, it's amazing that that thing came up just 2 weeks before and we knew what to do. So the thing is, though, I didn't know what to do. Fortunately, Steve and Jack, and then Dick Coors, and then, of course, Gene Krantz and all, and Jerry Woodfill, it was a nuisance alarm, but I had never come up with it. Go to the next one. And so here are the panels. These things were my responsibility. And there's another 2 lights. It's called the master alarm light. And they're one on each side of the pilot and then the commander's panel in the lunar land of the Eagle. But one thing I did right, if you go to the next one, go to the next one if you can get it. That's the thing I just talked about. Okay, this is the checklist, and that's the nuisance alarm situation. Well, I was thinking about all the things. I would go to around the United States, and I would have to lead the team of people that actually had to deal with nuisance alarms. And so I had to put all those in the procedures when they were a nuisance and just say, don't worry about it. Go to the next one. And so these were some of the trips I took. You know, that one that I mentioned earlier when I met Roger Chaffee, that was one. And later one, Spacecraft 12 trips and all these things. I go out to the manufacturer of the electronics for the lunar lander and the command ship's alarm system and all. These are the meetings I had to go. I'd be on the road a lot. Go to the next one. And, you know, people say, well, Jerry, we've never heard any of your stories. Where do these come from? Well, I said, they're true. I said, look, they are true. And I can prove them because of this document here. 2/3 of this document has to do with all those nuisance alarms and all the things we had to change so that the crew would know when there was a problem. And so when I was assigned the job, of the alarm system engineer, and my first day on the job was in 1966, and these are all the times I would call and go over with the manufacturers all the things and problems I could see and fix. And so this is like Columbus's log, you know, when he was going to the New World, and each day he'd enter in his log. Well, in here, every day I worked as the alarm system engineer. I have an entry, and it deals with specific things that we fixed on Apollo 11, 12, 13, all the missions that made the craft safer and the astronauts' lives safer. So I keep this. In fact, it's been a long time. You know, how many years ago? And so I've been going back through this book and actually reading some very interesting things. I can't believe I did this. It's been so long ago. You know, it's humbling, you know, when you go back and see what you did as a very young engineer. Go to the next one. Okay, so here I was in the mission evaluation room, and here's a man, he's a Grumman engineer, systems manager by Jimmy Reardon, wonderful gentleman, just a really sharp person. and the best part about him was he could communicate in such a wonderful way with people. And I always share that when I go out. It's not just what you know, but how you can share what you know with other people. And Jimmy had a wonderful ability to do that. So Jimmy and I were having lunch one day at Drummond Plant, and I said, Jimmy, I just thought, what will happen when the Eagle gets on the moon and it's landed, and here we are on the moon. And as they're on the moon, the descent engine here is very warm, as well as the alarm for the lunar landing radar. The temperature of that landing radar is into my system. So if it gets too hot or too cold, if it gets too hot or too cold with the landing radar, it's going to turn an alarm. Now, Jimmy, what will happen if Neil Armstrong and Buzz Aldrin have gotten out of the lunar lander and they're about to go on, and then the heat from the engine and then the firmware there turns on that alarm? Well, they'd have to cut off their moonwalk. They'd have to come back in. And what if they get out further away, and the alarm would also come on if things got too cold? What if they're out here and things get too cold where that temperature center is? The alarm would go off, and they'd have to come back and cancel the rest of the lunar lander. In fact, it may happen that Neil Armstrong wouldn't even have time to plant the flag because the alarm came on then. And then if the cold side turned it on, but he might be going up to talk to President Nixon in the White House, and all of a sudden, the alarm comes on. And Jimmy said, we better do a thermal analysis about the temperature of that sensor. And they did the analysis, and they said, Jerry, you're right. You're right. We're going to have to inhibit the landing radar temperature. Well, the landing radar, they didn't use the landing radar after they landed, so they inhibited that, and that's my big contribution to the Apollo 11 mission. In a sense, I think I may have saved the actual moonwalk, the plant of the flag, and maybe the call to President Nixon. Go to the next one. So my discovery, perhaps this might have been the case. I saved the flag planting and the call to President Nixon. Go to the next one quickly. Okay, well, having dealt with that, now comes Apollo 13. Now remember, when the program alarm comes on, I'm thinking, oh no, what a lousy job I've done. That's one of the nuisance alarms I've missed, and it looks like I'm virtually going to keep Neil Armstrong off the moon, and it's going to be, let's see, Armstrong, Aldrin, Conrad. It would be Pete Conrad then would be the first man on the moon. And so I thought, well, then came Apollo 13. I had my headset on, and it's 9:08 p.m., April 13th of 1970. And all of a sudden I hear in my headset, Houston, we've had a problem. And I look up at all those black and white TVs, and I see the screen doing unusual things. It's coming on and off, but I also see that the master alarm is on, as well as a number of other indications of failure. And I'm thinking, oh no, the program alarm, and now here this, again, it's my system has caused a problem. And then I heard Jim Lovell. You know, I had my headset on. You could actually hear Gene Kranz and Lovell and everything. You could hear the air to the ground in your headset. And Jim Lovell said, we see something venting. We see something venting. And it was a venting. An oxygen tank had exploded. An oxygen tank had exploded in the mothership right there, and it blew a panel out. And actually, that panel hit the high gain antenna. To see that antenna? And that's why I saw the flickering in the screen, because the communication on the high gain antenna was interrupted on and off. And it finally got stable, and I could see there was an alarm. But when he said he looked back towards, see, he could look back through his port window there, and he saw something venting into space. Oh, I said, something's venting. Oh, there is a problem. It's not my alarm system. In fact, my alarm system, because it came on, it was the first warning that the Apollo 13 crew had of that situation that might have taken their lives. And it's probably my big point in my whole career, because here's what it sounded like.
please. You point out about. Roger, main beam about. Okay, stand by there, Gene. We're looking at it.
Did you hear that? A pretty large bang associated, the caution and warning. That is my stuff. My system was the first alert when they said, Houston, we've had a problem. They had a main bus be undervolt, and the main bus undervolt is one of the measurements that actually tells you that this turn this alarm on. The alarm, and they hear a tone in their headset, and that tone gets your attention because it's very it goes like I actually had it in my phone, but we're running late. I won't be able to play that. Go to the next one. Okay, I had it. There it is. Okay, master alarm, main bus be undervolt, and right over there, that's that main bus be undervolt. And what they heard was, this is what it sounded like. Now, most of you have probably been to the movie Apollo 13. Please turn off. Okay. And in the movie Apollo 13, here's what they have it sounding like in the movie. Hear that? That's not how it sounded. Y'all have actually heard the real sound. Most people haven't heard the real sound that the astronauts heard, but you have. Next one. So that we've solved many grave problems and nobody ever heard of, but basically Apollo 15, we have a brilliant engineer. His name was Gary Johnson. And Gary is probably one of the brightest engineers that ever worked for the whole Apollo program. And he is one guy that through his knowledge and his expertise, he's kind of like a combination flight controller, engineer, he'd be great flight controller and one of the finest engineers, but he came up with something that saved the whole Apollo 15 mission because of what he knew and how he analyzed it. So that was one of the MER things. He said, there are many things that we were able to do to save missions. And one of which was, go to the next one. This is, I've shared much of this. These are the things. Sound the first alert, go to the next one page, okay? This is another thing that happened. The MER solved this one. When Apollo 13 exploded, when they tried to understand what had happened, and because they didn't, they went into the lunar lander, and they had to keep the power on in the command capsule, the capsule here, and the fuel cells wouldn't provide the power because of the explosion. So they had to use the batteries in the capsule, the reentry capsule, and they depleted them. And they depleted them so low that there was not enough battery power to get them back through Earth's atmosphere. Actually, they were dead men after that used depleted batteries. But one of our MER engineers had a procedure. He figured out how to take power from the lunar lander's large battery and trickle charge it through a jumper charge into the emergency batteries and repower it and save the astronauts' lives. Go to the next one. Okay, and that's him on the right. His name was Power Manager Art Campus. There were two main things that saved the lives of the Apollo 13 crew. One of which, of course, I just shared with you because you had to have battery power to get through Earth's atmosphere. But the other one, if we go to the next one, that's our jumper charge. That's my rendering of it. Go to the next one. This is the one that I really love to share because my system began to turn on what they call carbon dioxide warnings because the astronauts were using the lander as their rescue ship. And so in order to keep them alive, there weren't enough square filters in the rescue ship. So they had to come up with a way of making the square filters in the command ship, which this is my creation, the square filter. There were 24 of these, but there were not enough of the round filters in the lander, which had 3 men designed for just really 2 men, 2 days, but now they had 3 men and 4 days to get back to Earth. So not enough of these filters, but there are plenty of these. So the mission evaluation room and our had to figure out a way how to make the square filters work in the round system. And they did it by the name of Ed Smiley. He came up with this idea. He took bags for suit parts and moon rocks and put that filter in that bag. And then he knew we had a hose on board. Here's the hose. I got it at Toys R Us. And they went out of business, but maybe I can get some more. I heard they're going to be open during the holidays. So what he did, he said, well, if we take the hose and there's a fan on board that blows the cabin atmosphere around and blow it through that bag, and then if we put the square filter at the mouth of the bag, we can save their lives, except that it's going to leak. You see, that's going to leak. Well, the reason that we could save their lives is because somebody had put duct tape on board. So duct tape saved the Apollo 13 crews, but it was really Ed's technique and the mission evaluation room that came up with it. Okay, go to the next one. Okay, so we did that. I shared it with you. Let's go to the next one and made the square peg. I just gave the demonstration, okay. And because of it, the crew gave the Sylvester Award to the mission evaluation room team. And I love this. See, they put the panel of the caution warning system as part of the award. That's great. Go to the next one. And all of us that worked on it, I got the Presidential Medal of Freedom. In fact, it's hung over here in the office. And those of us that were on the mission operations team, Gene Krantz he got the same award I got. Now the astronauts, they got medals, and we all shared the award. So we got certificates. Go to the next one. Go to the next one here. And so, I've talked to it took 50 years, and I always wanted to be recognized by Rice University because I was such a lousy student and even a worse basketball player. But I said, I'd love to tell the story I'm telling all you guys around the United States. I'd love to tell it. Well, for some reason, I share this with students and career people, all of you out there, that don't ever give up on your dream. It took me 50 years for this to happen. But here, look at this. On the Rice website, they have put me here among Nobel Prize winners and Olympic asteroid and baseball players like Lance Bergman. I'm on the same list. It took 50 years, but don't ever give up on your dream. It could come to pass. Go to the next one. Okay, and so because of Apollo 13, I go around, I give this talk over and over again. And when I give it, I always show this to the people. I wear this wristband every day, and it says, failure is not an option on one side, and on the other side, it says, I have the right stuff. And you guys got it. And in order to actually explain that to people, I said, now, if you want to we're going to do a pledge now. I want to make you all, what we call honorary flight controllers. Apollo 13 or Apollo 11, we're going to make you honorary flight controllers. And I lead everybody in the pledge that I speak to, in the flesh. And at the end of the meeting, then if they take the pledge, they get one of these cards. I've signed it, by the way. My autographs were all $3.50. But I'm giving out so many of these autographs, probably down to 50 cents. But anyway, I give them each a wristband. And here's what I want to do now for the whole national audience. Okay, you guys ready? So bring up on the screen the final slide. Can you bring it up? The final one. And here's the oath of an honorary flight controller. And to do it, the way we do it is we put our hands over our hearts. So you are all about the United States and libraries. We're going to take the pledge together, and I'm going to take it with you. Are you ready? Is everybody ready? Okay, hands over the heart. Repeat after me. I will do my best to achieve success in my goals. Neither fear, failure, nor frustration shall overcome me. I am unstoppable, unmovable, and unshakable. Failure is not an option. I have the right stuff. And you all got it now. You're all honorary Apollo 13 flight controllers. I applaud you. Make a copy of that, print that out, and everybody that took it, put your name in there, and you are an honorary Apollo flight controller. Okay, that's it. That's my program. Thank you all for hearing me out. I really appreciate it.
And that is so awesome, Jerry. You know, being with you to go through this honorary flight controller, you know, it's pretty special because from someone like you to be able to, in a sense, you know, christen all of us, we so appreciate you. And for the folks that are out there, I hope you can see what perhaps we meant when we said how passionate Jerry is, because Jerry is truly a passionate individual who loves to share his stories that, you know, many people really haven't heard. So Jerry, thank you so much for sharing. And we have in the chat window things like awesome presentation. Jerry's a treasure. Thank you for the great motivational talk. And we do also have some questions for you, Jerry. Now, let me look at my, we have about 15 minutes or so. So if you have questions or messages that you want to be able to get to Jerry, the chat or the Q&A, especially for questions. And again, Jerry, just based on the chat window, there's a whole lot of applause going on out there. So thank you so much for your inspirational message. But let's get to some questions that came out from your talk. Now, a group from the Space Science Institute is wondering, you know, you talked about all these calculations. Did you do them by hand with pencil and paper?
Well, you know, we often have this happens again and again, and people ask me about this thing, and they say, what is this? And I show this in programs, you know, they say, what is that? Some toy that you got at Toys R Us? Well, we use that quite heavily. When I was a senior at Rice University, my pulse circuits book was with vacuum tubes and transistors. That's how long ago it is. And we did use slide rule. Sometimes you can beat a calculator with a slide rule, you know, even though it's an analog device, you can get an approximate answer very quickly. So yeah, we did a lot of this, and we do calculations, but you know, it's tough in real time when you have an explosion and so forth, and you got to be quick. So if you haven't done it beforehand, if you haven't done your homework, that is, done it when something happens, you have to remember what might happen, how to be proactive. And that's the thing. You don't get a lot of credit for being proactive, because if you're proactive and make it work right, then there won't be a problem. But if you're reactive and you didn't foresee the problem and it happens, then if you solve the problem real time, a lot of times you get a lot of credit. So that's what I always say about that landing radar thing I discovered. That was wholly proactive. Now, had it happened while Neil Armstrong was out and we solved it then, well, I don't know that I'd have been very popular, but I'm glad I solved it before we went to the moon.
And we certainly are too. And that Space Science Institute was from Colorado. And Dome on the Go, one of our groups in California, you know, speaking of serious issues, they're wondering during Apollo 1, what was causing the O2 flow alarm? And their understanding was that it was attributed to crew movement. Why would that trigger the alarm? And was there anything else that triggered it, if you could provide some insight?
Okay. That's interesting, because the O2 flow alarm was one of my big challenges, a very big challenge, because crew movement, when the astronauts would breathe very heavily, the sensor was so sensitive that would make that alarm come on. And it was a problem. And in order to inhibit it, they would have to pull a breaker on the sensor. And it was such a problem. And we hadn't really fixed it until I guess it was after Apollo 11, because Mike Collins, in his checklist, you can actually see where he writes in it, if you have the Pro O2 flow alarm, don't get too disturbed. It will come on even if they would, you know, you had a urine dump and would dump it into the vacuum of space. That would cause that flow to come out of the oxygen and it would come in and it would turn on that alarm. And so what happened was we had to write it into a procedure that do not worry about it. However, I wrote an engineering order later that it would put what they call a 16-second delay. So that O2 flow would have to be, coming in at a high level for 16 seconds before. And if the cabin punctured, and you're blowing atmosphere from the command module into space, you'd want it to come on quickly. But the problem was, it was a real issue. What was a nuisance and what was the real thing? So that's the thing I got involved with and had to deal with. Now, for the O2 flow on Apollo 1 spacecraft 12, yes, during those testing that afternoon, the fire can at about 6:29 p.m. on that Friday, I think it was. And that afternoon, it had come on because of breathing, heavy breathing, I guess, as the astronauts began to move about the cabin. And, that was an issue, but it really didn't relate to what the real fire source was at all. And I often wondered about that. And so I went and did a very heavy analysis. Remember I mentioned this guy, Gary Johnson? This guy is a wonderful engineer. Well, he pinpointed directly what caused the fire. And if you will go to the NASA website, the history office has it at JSC, oral histories, JSC oral histories, and you look Gary Johnson and read through his oral history, you'll find exactly the source of that Apollo 1 fire. And it's very interesting. A lot of people don't know it, but Gary really came up with the source years ago.
Awesome. And one of our folks put in the chat window a link to a history.nasa.gov AFJ link that might provide some additional information as well. So awesome. Well, here's another question from Manfred Olson Planetarium at the University of Wisconsin in Milwaukee. And they're wondering, you worked on a lot of complicated systems. What was the most complicated system you worked on, in your opinion? And tell us a little bit about it.
Okay, by far, the computer system, the guidance and navigation system. This was in a very primitive age, software-wise, way back, how many years ago, 50 years ago, and things like, calculators and your iPhone just didn't exist or anything like that, So I would say, well, the guys at Draper Labs and are really the guys that were in flight control that did the trajectory analysis and they knew it very well. And I didn't. And, it's like orbital mechanics and all those kinds of things. And they're very important. But the alarm system, for example, I told you about the program alarm, that was in that arena of the guidance and navigation system, the onboard computers and all that kind of thing. I was great on analog circuits, they're easy, but the digital things, and that was the primitive digital age, And so I remember I did some Fortran program at Rice University, and I did some basic programming, but I wasn't really for me, that was the most difficult thing. And I wished I'd have done more with it, but you know how many inputs went into that warning system? I think just on the lunar lander alone, I think it had 130. So every one of those things had to be analyzed. And then on the command ship, there were 300 switches and gauges, and all those, any one of those switches could be flipped and it would cause an alarm to come on. So it was an enormous job. And, I didn't do it alone, but I led the team that had to be encouraged to know that was what they had to be cognizant of.
Awesome. Well, speaking of technology, our friends at the American Museum of Natural History in New York are wondering if you could have any 2019 technology back in the 60s to aid with the amazing feats that you were a part of, what would it be?
Well, that's interesting because I have had a project that took all the analog systems and so forth, for example, the warning system. If I could take back with me the ability, the digital ability on a display and to take everything and digitize it, that's what I do. In fact, after Apollo, they asked me, well, Jerry, what would you do to make it a better system, the warning system better for shuttle? Well, what I did, I breadboarded a digital version of the analog caution and warning system. And I wrote a paper on it and turned it over to the shuttle guys. And the shuttle incorporated that approach, the digitization of the sensors and so forth. See, my alarm system was like this. The master alarm was digital. When it was triggered, the light would come on and the tone would sound. But that which turned it on was analog. And so the level of the electrical power or the temperature might come up to that point, turn on the alarm system, which latched up, and then it would descend, and you didn't know what caused it. It was like having a problem. You take the command to a mechanic and you can't, you see, it keeps happening, but it won't happen when you want to get your automobile fixed. So what I would have to do, I'd have to go back in the mission evaluation room and get the printouts of all the data, and then I'd have to lay out those, they were fanfold things, you know, and lay them out on the floor, and there wasn't much light in there, so I'd have to turn a light on and look at every one of those measurements and see if there's 1/10 of a second where there was one measurement that was coincident with the master alarm, and that was the culprit. So if I could just make everything digital, take all that digital technology back to that day, I would. And that's what we're doing for Orion. We have a program right now that I was the project manager of that does that everything in Orion will be on a CRT, and you won't have the system I had to struggle with back in the Apollo days. So I guess that's the best answer I can give.
And that's awesome. You know, in the digital age, it really is amazing what technology can aid us in doing, but can't stop us from using that mind, and the mind being able to help solve those problems.
It's wonderful.
So here's a question from our solar system ambassador in Arizona, and she's wondering, what experience from the 1960s have you applied or called upon for your work on robotics today?
I'm a project engineer. That's what I started out at NASA. And so that requires you to pull together all that you knew from college. And I had a physics textbook. I always say the best textbook I ever had was the Freshman 100 at Rice University. Was it called Sears and Szymanski? I don't remember it. But anyway, within that particular book, there are things that you can use to solve about any problem, even today. But you have to have the mentality of, well, I think, because I'm an engineer, tell you to be able to take those principles and look at things sometimes just from an empirical sense. What's happening? How do you explain what happened? From what's your, common sense stuff a lot of time. It's just common sense stuff. But then you have to take that common sense stuff and explain it from a scientific point of view. You have to be able to, things like F equal ma and all those Newton's laws and all those kinds of things. And so you have to, as an engineer or any kind, you're not just an engineer, any kind of, if you're in a medical industry or a doctor or a nurse or something like that, you observe things, and from those observations, you have to take and play that into your education and your knowledge. And that's what I've had to do my whole life as an engineer. Robotics is no different, all the rest of them. We have a robot called R2, and the way that we came up with the design of R2 was some of our engineers went to the Texas Medical Center and looked at cadavers to see how, actually the systems and the sinews and the nerve system. And actually they used the hand to model how the hand for R2 is actually designed and built. But, I can't say this is something that you just learn how to do, and you do it over and over and over again. I've had 25 projects. Some are not in robotics. Some are one was in laser, where you took a laser in an aircraft and you pointed it towards a river or a lake, and that laser beam would go down there and it would come back, and you could actually tell if there was any sediment or any pollutions in the water. And that was altogether different when I did with Apollo. And then I got into robotics, and, but it's the same kind of things. Robotics is a wonderful career for an engineer, because everything about it has to deal with the kind of things I'm talking about, you know, how to make an actual creation do the same things that a human body will do, you know, and that's going to take a wide variety of training and education and on the hands-on knowledge to do it.
Awesome. You know, it is just about the top of the hour, but Jerry, are you willing to stay on for a few extra moments?
I'd love to. Yeah.
Awesome.
I like these things because it's just like you have a new problem. You throw a question at me I've never had before. But the fun about it is to see what your mind will put together as an answer. And I suggest that to everybody. Have people ask you questions and see how you'd answer. It's a good practice.
It is a good practice. But for those of you who might need to depart and move on to other things during your day, first of all, I want to make sure to thank all of you for joining us today, because we know how busy you all are, and we so appreciate you taking some moments out of your day to be able to have us be able to share Jerry with you. I also want to thank Jerry, and this is the first of a couple of thanks to you, Jerry, because you are absolutely fabulous and inspirational. And after 54 years of working here at NASA, to be able to know that it doesn't get old. It's still exciting.
It does not.
Fun. We so appreciate that about you. At least I do, because I think that's so important for anyone out there, kids of all ages. If you love what you do and you do what you love, you'll never work a day in your life.
I attest to that. Great.
Awesome. Awesome. So again, if you have to depart, folks, thank you so much for joining us. We're going to, Brian Brooks, if you have the little link for the survey, if people want to just fill out a quick, brief survey for us, Brooks will put that in the chat window. But we don't want to distract from Jerry, so let's get back to Jerry. So Jerry, here's a couple of other questions that came in. Someone, let's see, where to go? Oh, Susan Runco, who's right here at the Johnson Space Center. She's wondering, how long did it take for the astronauts to learn about the different nuisance alarms? Same for the MER personnel. How long did it kind of take them to learn about those different nuisance alarms?
Okay. Well, the training, I haven't been in crew training, but I know something about it because of my involvement with the crew, with the alarm system. So what would happen was the mission controllers, flight controllers, they would take the information, for example, that I would share about the alarm system, or that Grumman would provide, or then North American would provide about the command ship. And they would take all that stuff and they would put it in a format that the flight controllers could readily use very quickly, that they could come up with a quick answer, because they had to. You know, the mission was only 7 days long, and sometimes a certain phase, it's just very, very brief. So you have to have an answer right away. And so what they would do is they would train the crew as you would, you know, when you have to be trained to drive a car, you know, you have to be trained to know what each one of the automobile controls were. And then you have to know in a spacecraft what each one of the meters represents, and then each one of the alarms represents. And, you know, when they did it, you know, they took out with them, they took a cookbook, you know, they had to have procedures. You know, that's another thing about the present, you know, you can Google it. I don't know if you can Google it from the book, but a lot of times when I need a quick answer from, you know, 50 years ago, I just Google something, and, you know, I put all my stuff on the internet, by the way. I would suggest, there's a site called the Space Educators Handbook, Space Educators Handbook. I spent thousands of hours putting all this institutional memory, my memory, and things that I had, my documents, I deposited them on the World Wide Web at a NASA site called Space Educators Handbook. So if you have a question, go to the Space Educators Handbook, or even Google something and put in there Space Educators Handbook, and it can answer your question. And so that's one of the things that I wanted to share is that the astronauts, they had cookbooks on board, But then for the basic, most important procedures, one of the most complicated things about going to the moon is how to use that computer. They had to know exactly what to punch in on the diski for what maneuver they're going to do. That was very complicated stuff. I never went through all that stuff, but each crewman had to know what actual P-32 meant or this or that, and what that would do as a maneuver. And then they had to sight their sextant on the stars, and then they had to punch in the coordinates. It was an enormous amount of work that they had to do. And knowing about my system was just a very small part of the whole perspective of what they had to deal with. And man, it was the average IQ of an astronaut, there were, I think, 37 Apollo astronauts, was 137, which is kind of almost genius level. It's Mensa, that would be almost a Mensa level. So they had to be very intelligent guys or gals. But in addition to that, they had to have other gifts. They had to be communicators. They had to talk with one another. And they had to be people that could get along with others. If you're going to spend on Mars months together, you have to have the ability to get along with folks. So there were so many things that those original 7 astronauts had to display, but now even more so for the new groups of Mars or shuttle or Apollo astronauts, not shuttle, Apollo astronauts. So yeah, it was very difficult. I mean, they would come by my desk. I had some astronauts that would actually come by my desk, and we'd talk about the alarm system, what makes this happen. Then I'd get calls I got a call from a gentleman named Orman Morris. He was over the whole lunar lander vehicle and everything. He calls me, and he asked me specifically how the alarm system can detect a runaway thruster, So that was a tough question, but I had the answer. But I asked him one time, I was at a function, I saw him at the function. I said, "Owen, why did you call me?" I said, "See, I was just a low-level project engineer, I was a GS7, $7,000 a year when I started out, and I think I got up to 9 when they gave me the alarm system, which was a little bit more, and so, no, but Owen said, "Jerry, one of the things about the Apollo program, we went to the people that had the answer. It wasn't a matter of your grade or your position on staff. It was if you had the answer." Now, that's what the MER had, the Mission Evaluation Room. They went to us when they're big, because we had the answers.
And could, Jerry, those issues that set off the nuisance alarms, could they be solved on board, or did they have to be solved from the ground, or both?
That's the answer, both. For
Okay.
Apollo 13, of course, if you've seen the movie, you see the ground working through the problems. This one I shared with you about the charging the entry batteries. If you go to, there's a video about Apollo 13 that NASA put out, and you see Art Campus, and then Gary Johnson, the man I mentioned earlier. Gary represented the command module, the command ship side of it, and Art represented the lunar lander power side of it. And together, see, they're working together because Art's got the source of the energy, the power, and then Gary's system needs to receive that and charge up those batteries. So that's where they worked it out. Well, then after they worked it out, they had to send it over to the astronaut. Charlie Duke was one of them that were working the simulator and try it out on the simulator. So it's a process, engineers, astronauts, flight controllers, it was both. That is to work out any kind of a new procedure to solve a problem. The one I always share about is the problem they had with navigating. They had to sight the stars. They looked through the sextant with their sextant there on board. And when Apollo 13 exploded, it threw all this refuse, all this garbage out into the vacuum of space, and it enshrouded the vehicle. So as they were going out to the moon, they had all these particles of that exploded tank. So if you went to look out the port window, you couldn't see stars. And of course, you need stars to navigate. You have to know what the position of a star is to push it into the computer to navigate. And I always tell this story. Jim Lovell navigated Apollo 8, And he was the navigator. You remember Apollo 8 is the one that went around the moon on Christmas Eve and so forth. And, well, Jim, on Apollo 8, he sighted a star sighting, and he had the coordinates, but when he entered the number in the keyboard for what they call a display and keyboard to the onboard computer, he actually, instead of hitting enter, he hit erase. So he erased what he had discovered. So I tell this story, my neighbor down the street, see, we all lived in the same community. He worked for TRW, I worked for NASA, IBM people, all these different folks were a team. So we were having dinner one night, and I told him about what actually became the solution. And he said to me, Jerry, I tell you what happened on that. I was having lunch one day in the TRW cafeteria, and I thought, what if astronauts can't see stars? Well, it's not like being, in Earth where you got smog or fog and you can't see stars. Space is a vacuum. He said, but what if you couldn't? So he came up with this way of doing it. If you just sight your sextant on the Earth, the terminator specifically, on the moon, and even the sun for 3 positions, 3 coordinates in space, you could use that if you had the proper equation in the onboard computer as well as mission controls computer. You could navigate that way. And who knew that they'd ever get to that situation? But Jim Lovell, because he hit the wrong key, he tried that procedure out on Apollo 8, and on Apollo 13, it actually saved their lives.
Wow.
So the same guy that tried it out on 8 used it to save the crew's lives and navigate on Apollo 13.
That's an amazing story. Wow. So I have 2 more questions that are somewhat related. So one of them comes in from our solar system ambassador, and she's wondering, have you toured the revamped command center, the revamped mission control? And if so, what do you think?
Okay, here's the deal. For years, I would give talks in the Mission Control Center. They call it MOCR, Mission Operations Control Room. When you say MCC, Mission Control Center, that's a larger entity. But the MOCR was the focus of everything, really, I guess, Jim and I, as well as Apollo. I don't recall that we had any Mercury missions out of that. We may have. I think most of them were done from KSC, but nevertheless, see, here's the thing about me. A lot of times people think I'm kind of what they call an advocate for something called the Mission Evaluation Room. Because nobody knows a thing about us. So if you ask me about the MOCR, I quickly talk you about the MER. Because that's where I work, and Don Arabian worked, and Gary Johnson worked, and our campus, every one of us worked, So during missions, I never once went into the MOCR, but Gary Johnson, he's a brilliant guy. He used to work in the office next to me. He would go over there, and he and Don Arabian, they came up with procedure that they took over the flight controllers, and one of them, which was that saving Apollo 15. But nevertheless, yeah, I've been in there many times, but I have best time doing is comparing to the primitive nature of our MER room to the MOCR, because I read about what they did in the MOCR, and they said they had a problem with carpet, because everybody smoked. Well, one thing, our MER guys never smoked, but then again, we never had any carpet either. and so our chairs you could have replaced, just go down to the library. They're still probably around here. So the fact that, they've done a wonderful job, by the way, of upgrading they didn't upgrade anything, but they just restored it to its original either condition, or they found an identical part. And the outfit up in, what is it? You probably can tell me the name of it. Sometimes I have senior moments when I give these talks, but the guys that they had Apollo 13 after the, actually the capsule was there anyway. But anyway, they put all these things together. So just as a joke, I said, well, what if we wanted to restore the mission evaluation room?
That's what I was thinking.
So I went up to the location. I have a real special friend. He's from Wales. His name is Craig Scott. And he just loves the stories about the mission evaluation from the MER. He actually went and visited Don Arabian Don's 94 years old, and he's still sharp and everything, you know. So Craig and I always talk about, and Craig suggested that about 3 years ago, and I said, well, I don't know if we want to start that right now. We got to get the MOCR redone, you know. But last week, just for an enjoyable kind of a thing, I went and I just listed all the things that were needed to restore the MER, the mission evaluation. I got picnic tables, black and white RCA TVs on tripods. And then I said phones, you know, they had to be the rotary phones. That's what we had, you know, binoculars that we had on the table. And I listed all this. I had 10 different categories, and I priced it all, and it came to $1,192.
Sounds like we can do that cheaply.
So someday, maybe I'll just donate that to whoever's going to take it. Maybe I'll try to do it myself, you know. But really, the MOCR is a wonderful job they've done, and the tours. In fact, they're having a big deal. Go online, and Space Center Houston has really got a tremendous program outlined for the days, you know, starting, I think, about the 16th, 17th, 18th, 19th, 20th, 21st, you know. And so I'm getting, I wanted to be one of the speakers. Nobody ever asked me to be a speaker, you know, for that. So you don't know this, but I do guitar, you know. I have my guitar in my office here, you know, and I do songs. I take the 1960s and 50s songs and I adapt them to space themes, you know. So I'll take a song like Elvis Presley had a song, Return to Sender. So I'll recreate the lyrics, you know, return to orbit, you know, address unknown, please don't call us, there's no phone, you know. So I redo the lyrics, you know, and then I perform them to a students group. And I speak to 4-year-olds to 84-year-olds, you know. And if you bring out your guitar and do songs, you keep your audience engaged, I assure you that. And I was going to do my duct tape song, but I didn't think I better do it for this program, you know. But it's my most popular creation, my duct tape song.
Well, maybe another day we'll have to have you do some songs.
But anyway, so I wanted to be in the somehow be, you know, give a talk about the MER, and so I, you know, everybody, you know, Gene Kranz and Glenn Lunny and all the flight controllers, everything, you know. And so the person that's kind of coordinating this thing, I happened to mention that I did this, what's called Rocket and Roll Apollo 11 50th anniversary show. So on the 20th at 1 p.m. in the afternoon, at the Rocket Park at the nose of the Saturn V, I'm going to perform my Rocket and Roll Apollo 50th anniversary show. When I do all these songs, I do the Kennedy talk in its entirety that I know it anyway, and all the other things that actually saved Apollo 11, and they're very, very interesting. So, and then everybody's discovering me for some reason. And so, you know, the Deborah Duncan shows has me coming on. I'm going to do talks about it. And then there's something on Channel 39. I'm going to do one there, you know, in the morning. It's a long drive to get over there, but I've got all these programs that I'm going to do. And my son's a pastor, so he's asked me to come to his church on the 21st, is the Sabbath day of the actual, you know, 50th year. And so I'm doing a talk at his church. And then Lunar Rendezvous, every year they have what they call the sunset service that launches the entire festival. So I'm going to be the speaker for that. So I'm looking forward. I got about 9 meetings in about 3 days. So y'all remember me, because it's going to be tough.
Well, you know, we're sure glad that we were able to have you as a guest speaker to be able to share a little bit about the history of Apollo, all your important work with the mission control room there and the mission evaluation room and the importance of that. And so we are so glad, Jerry, that we had an opportunity to share you with our folks out there and for those that'll watch the archive as well. So thank you so much for being such an inspiration and really such a treasure trove of information about not only the history of Apollo, but how you can take those lessons learned and keep moving forward as we go into the current and future of space exploration.
I'm going to compliment you, Paige, and Susan. You guys have done a great job of putting this together. And let's do it again. I'd love to do it again, whatever group you have. And those of you out there, if you want to do a Skype show, I can do a Skype show from my office with you and your class or your group. No, I'd love to do it. So,
sounds awesome. Great. Well, with that, it is about 20 minutes past the top of the hour. So for those of you that stayed on the line, thank you so much again for joining us today. We look forward to bringing you additional programs in the future. And thank you again, Jerry, for sharing again all of your knowledge, expertise, and passion for all of our folks that joined us today. So enjoy the 50th. If you're in Houston, go to Rocket Park at 2 p.m. and you can hear Jerry sing a few songs and sing a few tunes. If not, we hope you enjoy your 50th anniversary wherever you may be. And we look forward to going back to the moon, to Mars, and beyond.
that's wonderful.
Yes, thank you so much, Jerry. With that, we bring this to an official close. Thank you again, everyone. Have a great day.
Godspeed.
Thank you, Jerry.